Well, Elrod, I see you survived too. Fantastic. Where's the rest of the kitty crew? They're around here somewhere, aren't they? Hey, come on, Spook. Come on, you shackalacker. I see you made it through too. Yeah. Well, if you did, I'm sure Speedy and Cleo did. Hello there, friends and family. Glad to see y'all again. Or at least I think I can see you. Well, if you can see me, yeah. We survived again. Against all odds. Or so many would like you to think. And you might wonder what old Mr. Tom's talking about today. Well, he's talking about that event that's been hyped up over the last 3 days. You might have missed it, but I couldn't miss it. Because it started popping up on my news feed, mainstream media. Yeah. Oh, and ever more so on social media. On all types of channels. You know, gardening, homesteading, and prepping. Oh, they were losing their minds. So what was old Mr. Tom talking about? And what was all the fervor? Well, if you don't know, according to all of them, and that there was going to be this massive, catastrophic, life-changing event that originally they predicted for October the 11th, but people made mistakes, even scientists, and it didn't happen till October the 12th in parts of the world. And what was that? That was a coronal mass ejection. Yeah, a CME. And that's a solar storm, a geomagnetic storm, produced by a solar flare from the sun. Yeah. And it was coming straight to the earth. And at 2:30 UTC time, that's universal time, which just so happened to be 9:30 p.m. here in my little part of the world in the deep south of Alabama. Yeah. And as luck would have it, I was actually watching a YouTube channel live that tends to also hype up any possible event that can motivate people and just scare them into a worked up frenzy. Oh, and we got our other bigger kitty here. Stella, so glad to see you survived too. Yeah. You want to say hi? Want to say hi? You do, you just want your belly rubbed, huh? Glad you survived too. Well, let's walk, Stella. You and the kitty crew, okay? So anyway, as I was watching that channel, and keep my eye on the CME, and that, had a few websites open, I just found it rather hilarious. As they were talking about potentially what could happen, or what might happen, or what maybe happen. See, those are the key words you got to look for in all the articles, all the talking head speeches, all of it. They always leave themselves a way out. Could, may, might, yeah. Always notice that. It's never a definite, it's never a will. No. It's always got an escape plan. Yeah. So if anybody hammers them hard about, you said this, well, here I am. Once again, it didn't happen, didn't cause any problems. They can always say, well, you might have missed it. We said could, or may, or might. Yeah. It's when I see those three words, and that, I always check into it myself. And it's not that I spend a whole lot of time tracking solar weather, but I do casually keep an eye on it. But here's another thing. Is there anything in the world I can do to prevent it? No. Is there much I can do to make my life better? No. Yeah, some people say I could build a Faraday cage, put all my stuff in it, and everything. Well, here's my thought on all that too. Well, maybe all my stuff's protected, but most likely not. Things that it needs to connect to, if you believe everything they put out there, well, it'd all be gone anyway. So the fact that my stuff still works, what's it gonna matter? So, what was supposed to happen? Well, since they were hyping it up to be a massive major event, well, they were really pressing power grid's gonna go down. Yeah. Worldwide. Yeah. Yep, satellite communications will be disrupted, and possibly satellites could start falling out of the sky. Yep. Sure could. Some, depending on what their agenda and focus on, oh yeah. All kinds of earthquakes, volcanic eruptions. Man, it was just going to be Armageddon. Or like I said, could be. But is that really what would have happened? Or could have happened? And what exactly did happen? Well, if you're out there and you're a survivor like me, a survivor of the great 2021 CME event, well, maybe you want to know. Okay? So, just for y'all, in case you're interested, we'll wander on in to my computer command center, where I keep an eye on some of these things, as I do many more. And I'll just go through it with y'all. And that way, if you'd like to keep an eye on it too, you can do so. So y'all, we're in here at the old command center. And what you're looking at is what's called an aurora, or the northern lights. Okay? Now normally auroras are seen in the upper latitudes of the northern hemisphere and southern hemisphere. Now the auroras are normally only visible in the northern and southern extreme hemispheres, or in the northern and southern higher latitudes. Now, what are they caused by? Yep, they're caused by solar storms. Magnetic waves that skim across our planet. And they do this quite often. And that's exactly what happened on the very early morning hours of October the 12th. And since I'm sitting here talking to you, and you're listening, it would appear, for the most part, we all came through it. Now, if you would like to know more about it, where would you go? How could you keep track of this? How could you get some warning of just what's going on? Well, I'll tell you. And it all starts right over here at this website. So where are we at now? We're at a website, spaceweather.com. And I'll leave a link to this website in the description below the video. So, in case you're interested, and you're concerned about such events like CMEs, sunspots, and what have you, you can track it too. That way you just don't gotta listen to somebody on YouTube that may, for whatever reason, be drumming it up a little bit more than what it might actually be. So what do they got to say about the geomagnetic storm that hit our Earth on October the 12th? Well, as you can see here, it says the Earth's magnetic field is reverberating from the impact of a CME during the early hours of October the 12th. At 2:30 UT, that's Universal Time, the blow triggered a G2 class geomagnetic storm. Actually a double storm, which is now subsiding more than 12 hours later. Oh yeah. Arctic sky watchers should remain alert for auroras as the Earth exits the CME's magnetized wake. Now, it goes on to say, auroras in the USA. It's been a while. Last night, auroras were sighted in more than a dozen U.S. states after CME struck the Earth's magnetic field. The G2 geomagnetic storm produced the first visible auroras from coastal Massachusetts since 2017, reports Chris Cook, who snapped this 30-second self-portrait around 1 a.m. Eastern Daylight Time. And you can see him there standing on the beach looking out at the beautiful colors of the aurora. Now, as it said, since 2017. So it's not like this hasn't happened before many times, nor will it be the last time it happens going forward into the future. The red-topped auroras Cook witnessed are relatively rare. They appear during geomagnetic storms that spread far from the poles. Red is caused by the oxygen atoms meeting the solar wind as high as 500 kilometers above the Earth's surface. In some states, the auroras were so bright, onlookers photographed them using nothing more than their cell phones. The iPhone photo on the left comes from Tyler Knight of Mound, Minnesota, while the Samsung Galaxy image on the right was taken by meteorologist James Simcoe on Castle Hill, Maine. Across the border in Saskatoon, Canada, Frank Lane recorded a must-see video using his iPhone 12. The display was dynamic, producing many curtains and pillars, says Simcoe. At the apex of the storm, auroras descended as far south as Nebraska. Carl Bond photographed the faint red glow from the town of West Oak. Subscribers to our space weather alert system, which you can do too, and they'll alert you to your phone or to your email, like I say, if you're interested, were notified the instant the CME hit. The alert was triggered by a sudden uptick in solar wind speed, signaling the arrival of the shot front. And what he's showing you here in this here illustration below is the solar wind speed on October the 12th, 2021, and it points out exactly when you could see the CME impact. And it's clearly visible that the solar wind speed increased dramatically. The plot shows data from Noaa's Discover spacecraft when the CME passed by the solar wind quickened by 120 kilometers per second. At the same time, the plasma density tripled and the temperature increased almost tenfold. These are classic signs of a direct hit by a CME. So there you have it. That's exactly what happened at what time on October the 12th. And I actually was wide awake, because I'm a curious kind of guy, living the events, waiting for all the devastation and catastrophe to fall upon us. No, I had no confidence that was going to happen. And we'll talk a little bit more about that when I take you over to another website. But something else I want you to know about this website, just in case you're interested. You can also track near-Earth objects. What are they? Those are those asteroids that are going to wipe us out off the face of the Earth that you hear about all the time. Well, here, you can actually come down here, and they have it right here, near-Earth asteroids. Potentially hazardous asteroids are space rocks larger than approximately 100 meters that can come closer to the Earth than 0.05 AU, and that's astronomical units. None of the known PHAs, is on a collision course with our planet, although astronomers are finding new ones all the time. It shows you right here a list of ones that have went by and those pending. Like if we look today on October the 12th, right here, you can see 1, 2, 3, 4, 5, 6, 7, 8 different near-Earth asteroids that buzz by our planet. Now you'll notice they're measured in LD. Just so you know what that is. That's lunar distance. So let's take one right here. The first one, 9.6 LD. That was actually 9.6 times the distance between the Earth and the Moon. Okay? And it was 16 meters, or no, 29 meters in size. That's a pretty large rock, right? But it didn't come all that far. And it tells you right down here, LD means lunar distance. 1 LD, this is what you need to know, is 384,401 kilometers. Yeah. That's a whole bunch of kilometers just for one, let alone 9. But you can see, some get much closer. But here again, if this is something you're interested in, you can check it out and keep track of it right here. And get a warning when the Earth may have an asteroid hit. But another site I want to bring you to that talks more about CMEs, and that and tracks them, is actually a Noaa website. Let's go there now. So here we are at the Noaa Space Weather Prediction Center. Yeah, National Oceanic and Atmospheric Administration. And you can see space weather conditions. 24-hour observed maximums. And you can look up, what these mean and that. Let's see, they show a G2 moderate was observed for today, the 12th. The latest observed being present time right now as we speak is nothing. Predicted, this is what was predicted for the 12th of October. A G2. And that's exactly what we had. What's predicted for tomorrow? Nothing. What's predicted for the next day, the 14th? Nothing. So by coming to this website, you can at least get 2 days heads up and take whatever precautions you feel you need to do or are necessary to protect you from the next devastating CME. And you can see right down here just what exactly happened. You can see when the first wave came through, the second wave, how it affected the solar X-ray flux, and I'm not going to get into all the meanings of all this. If you're so interested, then you need to do some learning here and do your own research. You can see the solar proton flux never got out of the green. But then when you get down to the third chart there, the geomagnetic activity, you can see what transpired over today, October the 12th. And these are in 3-hour increments. So in the first 3 hours, you can see when it first arrived. And it went up to a minimum G2. Then, from 3 to 6 UTC in the morning, it went up to a maximum G2. That was the first wave. Then, it calmed back down to where it might have been almost going to be a G1. Not quite. And then the second wave came through, and it spiked up again to a maximum G2. And since then, everything's been calm and well. And you can read over here the 3-day forecast on the right. It shows you over here at just what times on October 12th. You can see there was a G1 at 3 Universal Time, a G2 at 6. There was still a G2 at 12, and a G2 at 3 o'clock this afternoon. Then, as you can see in the third chart, nothing. So the rationale here, a G1 to G2, minor to moderate. Storm conditions are expected on the 12th of October in response to CME effects. Well, we now know that's exactly what happened. Solar radiation, as observed by Noaa, goes 16 over the past 24 hours, was below the S-scale storm level thresholds. Yep, and that's shown right here. Solar proton flux, that's radiation. It never got out of the green, like I said. Rationale, no S1 minor or greater solar radiation storms are expected. No significant active region activity favorable for radiation storm production is forecast. So as of right now, as I'm speaking to you, all is fine and well, and life has went on. But down here you can see the solar winds, and you can actually see again when everything hit. You can see the increase and the disruption. Over here, if you'd like to play it, you can see how things played out. And they even have an aurora forecast. And it will show you, once it loads, what the aurora will look like. And you can see there it's growing, it's growing, it's growing, came down into the upper United States. See that? And now it's subsiding. But this is a good site also, which I will leave a link to in the description below the video, so you can check it out, keep track on it, and always have 48 hours advance notice of the possibility of the apocalypse. So other than a fantastic light show that was actually amazing and quite beautiful, that could be seen in our northern latitudes to the north, did anything actually happen from the CME that impacted the Earth today? And, the resulting geomagnetic storm? Well, the short answer would be nothing I could find. But you see, that does not stop people that wish to perpetuate the hype and hysteria all around the globe. They scoured the globe in search of every actual occurrence of anything of consequence. Such things as power outages, earthquakes, volcanoes, severe weather, you name it, that they could possibly tie in, that could have possibly been an effect of the CME. Now, they didn't give any regards to actually if any of these events correlated with the time the CME was impacting the Earth. No. But they know, as I know, that most people, the vast majority, won't even dig deep enough into it to know if these occurrences, regardless of what they were, had any equivalence to the CME impact in the time of its occurrence. They just go on. They'll nod in agreement, and they'll listen and watch and wait for the next. So going forward in the future, if you care and if you want to know, there's a few things you need to know so you can be better informed the next time you start hearing the hype and hysteria of an impending CME event. Yeah. And to do that, you need to learn the G scale, or the Geomagnetic Storm Severity Scale. Now what you're looking at now is a 5-level scale known as the G scale, And what it does is it measures geomagnetic storm intensity and strength. And they're rated from G1 to G5, G1 being the most minor and G5 being the most extreme. And what you saw today, as I've previously shown you, when the CME impacted the Earth, we saw a G1, which is a minor geomagnetic storm. And what could possibly happen here, and I say possibly, is a weak power grid fluctuations, minor communication issues, high latitude auroras. Now, something to bear in mind. The worst effects from any CME and its resulting geomagnetic storm will be more severe the higher in latitude that you are, whether it's to the north or to the south. The next level of geomagnetic storm severity is a G2, moderate. And that's what eventually happened today. Twice. And what can you see? What could possibly happen during a G2, moderate magnetic storm? High latitude power system issues, minor communication issues, and the aurora are visible in New York and Indiana. In any state, I might add, and or country, along that same latitude line. And if you're not familiar with latitudes, they are horizontal lines that are grid along the Earth, starting at 0 at the equator and going positive to the north and negative to the south. But the next level of geomagnetic storm severity is a G3, which is rated as strong. Voltage corrections required, GPS issues and satellite disruption, mid-latitude auroras. And what do they mean by mid? You're going to be talking about states like Ohio, Illinois, Iowa, just draw a line across the U.S. or the world. In those regions, we'll be able to see the aurora to the north. Now when they say voltage corrections required, the voltage along our power grid fluctuates every day. During a geomagnetic storm, corrections to that voltage level may be necessary by your power generation companies. And they are more than capable of performing that task. Now the next level is a G4, which is rated as severe. At that level, you'll see power voltage control problems, satellite tracking problems, aurora viewing possible in North Carolina, Alabama, and Tennessee, here in the U.S. Like I said again, you have to draw a line across those states, run it around the globe, and whatever countries and areas and regions fall along that line as well, you should be able to see that aurora as well. So what do I mean by voltage corrections required? Here again, they have to make corrections to the power voltage to keep it constant and at the proper level. Now, the fifth level, the most extreme, is a G5. And it's at this level that we could see power grid failure, major satellite failures, and auroras all the way south to the Caribbean. Yeah. Puerto Rico, the Bahamas, Cuba, yeah. As well as all latitudes north of that, as well as south. Pretty much the entire Earth. Here again, though, those living in higher latitudes will see more severe effects from a resulting G5 magnetic storm than those living in lower latitudes. And there are reasons for that. And the reasons are because the Earth does have a protective shield. Without it, life here on the planet could not exist. And you may have heard this back in junior high, high school, and even in college, depending on what courses you took. And that's the Earth's magnetic field. Think of it as a force shield. You know, like Star Trek. Raise your shield, Scotty. It is that magnetic field that protects the Earth from a variety of space weather impacts. But by knowing the scale from G1 to G5, when you start hearing from others of what is coming our way, or maybe now you're tracking it on those two websites that I gave you, and you see Noaa predict the G1, now you'll know. And what I would do, so it would always be able to refresh my memory, I'd screenshot this screen, I'd store it in my phone or on my computer. Because if you're old like me, you might want to refresh that memory from time to time. But now, knowing the scales, now you know whether the hype and hysteria that's being generated is actually going to be a reality, or if it is just that, hype. As I said, there is a shield around the entire Earth, and that is our magnetic field. It's there 24/7, 365 days out of the year, protecting the Earth from the effects of a geomagnetic storm. Yes, sir. And it's pictured right here. Of course, this one's a little bit graphic, and that's for impact. But you can see the blue lines emanating out of both poles, and each one represents a layer. Yeah, and it extends quite far out in to space, and you can see slightly a different shape depending on which side of the Earth is facing the sun. And you can see the side of our magnetic field that's facing the sun looks quite different from the side that is not. And that's because there's constant solar winds from our sun and magnetic waves, albeit nowhere near as severe as when a CME is headed our way. And it is these solar winds and particles that compress our magnetic field on the sunward side, as is pictured right here. And here again, there's a reason why the higher latitudes see more effects from a CME than with the lower latitudes. And that just goes with the strength of the magnetic field, which decreases as you go higher and higher latitudes towards the poles, and is weakest at the North and South Pole. Yep, that's a fact. That's why you can see the Aurora Borealis, the Northern Lights, which you can normally in the North Arctic Circle and the South Pole. So there you go. You know a few things. And if you'd like to learn more, check out the two links that I'll leave in the description below the video. I don't claim to be an expert, but I do know enough that when people start getting all stirred up and throwing out there everything that's possibly going to happen, and I've seen this happen, when Noaa has predicted nothing more than a weak G1. Oh yeah. They start talking about power grid collapse, internet going down, yeah, satellites falling out of the sky, more severe earthquakes, weather, yeah, volcanoes erupting, and the list just goes on and on and on. Some of them rather get fantastical. But now you know just what to expect. Now you know where to go to know what's happening and what's predicted. So I hope this helps you. It has helped me through my research to understand what to expect, what is real and what isn't, what's worth worrying about and what is not. And like I said, in all reality, Should a G5 strike the Earth again, which they are thinking, that the infamous Carrington event that hit the Earth in the year 1859 was an extreme magnetic storm of the G5 level. Yeah. And you can read about that. And there were a lot of newspaper articles about what happened. Telegraphs working all by themselves. Telegraphs catching fire. Well, actually, it wasn't a telegraph mechanism. It was the paper in the telegraphs which punched what the telegraph was sending. And even so, these were low voltage, DC operated devices that were connected between all cities and towns all across the world. And we even put in transatlantic cables, undersea cables, to connect to Europe and points beyond. And all of this was operated by low voltage lead acid batteries, which produced DC current. Now, it was reported that electrical systems were disrupted. Well, you see, that's where even back then there was some hysteria. A little bit of history for all of y'all. The light bulb wasn't invented until 1978 to 1979 by Thomas Edison. And I think it was actually a British inventor. I might have got that wrong. Could have been a French. I'm not sure. Mine escapes me. But you can look it up. That invented it the year before 1978, with Edison inventing it in 1979. And further research, when I was reading all about the Carrington event, because that's what all the hysteria is based on, is the first electrical power generating station for the public in the U.S. wasn't even installed and operating until 1882. So how in the world were any electrical systems affected by the Carrington event in 1859? I've scratched my head on that one. But hey, there was hysteria back in 1859, just like there still is in 2021. So anyway, folks, I'm glad all of you survived, as I survived. The Kitty Crew, Gracie, and Stella survived. And I hope this video has taught you something, didn't bore you too much. And until we see y'all on the next video, y'all stay safe out there. Take care. Prepare as you must and desire. May God bless you as you bless others. Till we see you on the next video. Good night and goodbye for now.